ఫ్యాక్టర్స్ మల్టిపుల్స్. దీని మీద మనం నాన్ రొటీన్ క్వశ్చన్స్ని సాల్వ్ చేద్దాం. ప్రైమ్ నెంబర్స్, LCM అండ్ HCF, ఫ్యాక్టర్స్. సో ఈ 3 టాపిక్స్ మీద వచ్చేటువంటి కామన్ క్వశ్చన్స్ని నాన్ రొటీన్ ప్రాబ్లమ్స్లో ఎట్లా సాల్వ్ చేయాలనేది మనం డిస్కస్ చేద్దాం ఈరోజు క్లాస్లో. సో ఒకసారి కూడా జై శ్రీకృష్ణ పెట్టండి కామెంట్స్లో. అందరూ కూడా జై శ్రీకృష్ణ పెడితే మీ దానికి అటెండెన్స్ నేను కలెక్ట్ చేసుకున్నట్లుగా అవుతుంది. సో వాయిస్ క్లారిటీ ఎలా ఉందనేది ఒకసారి రెస్పాండ్ అవ్వండి. సో మీ తాలూకా డౌట్స్ ఏమైనా ఉంటే దాంట్లో రైస్ చేయండి. కామెంట్ సెక్షన్లో డౌట్స్ రైస్ చేస్తే దెన్ ఐ విల్ గెట్ దట్ ఇన్ఫర్మేషన్ అండ్ ఐ విల్ గో త్రూ ఇట్ అండ్ క్లారిఫై ద డౌట్స్ హియర్ ఓన్లీ. సేమ్ టైం ఈ వర్క్షీట్ అనేది గ్రూప్స్లో ఫార్వర్డ్ చేయడం జరిగింది. ఒకసారి వర్క్షీట్స్ని కూడా గో త్రూ అవ్వండి. ఆఫ్టర్ ది కంప్లీషన్ ఆఫ్ ద సెషన్ వర్క్షీట్ని మీరు సాల్వ్ చేయాల్సి ఉంటుంది. సో అది రేపు సెషన్లో దాని మీద డిస్కస్ చేద్దాం. ఒక 2 minutes వెయిట్ చేద్దాం. రిమైనింగ్ విల్ బి జాయిన్డ్ ఇన్ ద గ్రూప్. Meanwhile, all of you list out the prime numbers from 1 to 100. List out the prime numbers from 1 to 100. I'll write on the board. You also have to write. All of you list out the prime numbers. సరిపోయింది. So you know regular questions from these prime numbers. We'll do some different concepts by using these prime numbers. So by using this prime numbers, we'll do some applications. For example, let P be a prime number. Let P be a prime number. So how many natural numbers less than P? Number of natural numbers less than P. How many natural numbers will get? Once observe here. Answer in that comment box. How many natural numbers less than P? If P is any prime number, among these prime numbers or any other prime number, let P be a prime number. So how many natural numbers less than P? That is the question. Okay, good. So P minus 1 natural numbers are there. Natural numbers less than P. Okay, so before going to discuss about this point, so let me know the definition of co-prime. What is co-prime? Respond children, what is co-prime? Good. Let J, Y be two numbers said to be co-prime. Said to be co-prime. And one more thing, whatever the notes is there on the board, after completion of the session, this PDF will be posted in our class groups. You can rewrite the notes after completion of the class. Meanwhile, whatever the important points, while listening, you have to write the notes. Every child have to write the notes. I'll give the sufficient time to write your notes. See, two numbers are said to be co-prime if their GCD, which is known as HCF, is 1. Here you have to observe one thing, that is these two numbers no need to prime. This you have to underline. These two numbers no need to prime. Any of them no need to prime. For example, if you will take 9, 16. So it is a composite number. What is their HCF? Both 9 and 16 are not there in same table. So that HCF is 1. So here 9 and 16 is co-prime. So why sir, what your heading is P be a prime number and natural numbers less than P. How many are there? P minus 1 is there. P minus 1 natural numbers are there which are less than that prime number. Immediately what we are discussing, co-prime. What is the relation between these two? There is a beautiful relation between these two. What is the relation? I'll write here. See, how many natural numbers are there here? P minus 1. So in this P minus 1 natural numbers, number of numbers less than P and co-prime to P is, see how many less than P? How many less than P here? P minus 1. So that number of numbers less than P and co-prime to P is n minus 1. This is very important point. Have to write this point. Based on this number of numbers less than P and co-prime to P is P minus 1. This you have to observe. Okay. So this is p minus 1. Right. So if I'll give a number here, suppose 97 is prime. 97 is prime. So number of numbers less than 97 and co-prime to 97. Number of numbers less than 97 and co-prime to 97 is 96, which is 97 minus 1. Okay. Now the second point is let P be a prime. Let P be a prime. Once observe here. Let P be a prime. Okay. N is natural number. N is natural number. Now P power n divisible by what? Right? This is the question. P power n divisible by what? So this is also we'll go through with an example here. So 2 is prime. Okay, 2 is prime. Suppose if you will take 2 power 5 is divisible by what? Yes, that is the question. 2 power 5 is divisible by what? So here, see, 2 power 5. 2 power 5. So this 2 power 5 is a prime number. You know this. 2 power 5. So before this, you know 2 power 4, you know 2 power 3, you know 2 power 2, you know 2 power 1, you know 2 power 0. What is 2 power 1? 2. 2 power 0, 1. 2 power 2, 1, 2. 2 power 4 means 2 times 2 multiplied itself will get 4. This is 8. This is 16. This is 32. And what we are asking, 32 is divisible by what? 32 is divisible by these 5 only. Right? So how many numbers less than 32? Number of numbers less than 32 is 32 minus 1, which is 31. So among 31 factors of 32 are, what are the factors of 32? See, these 5 are factors of 32. 1, 2, 4, 8, 16, which are all 2 powers. And here we have to observe, except 2 powers, remaining will not divide 32. Except 2 powers, 32 not divisible by other numbers. Except these 5, remaining numbers will not divide 32. So what is divisible by? You know very well. Divisible by means, what is the remainder? Divisible by means, good. Remainder is 0. So remainder 0 means we have to use the word divisible. Otherwise, divide. That is the difference between divisible by and divide. When we have to use the word divisible by, in the case of only remainder 0. It is also called as, when remainder 0, the divisor is called factor. We know that very well. Okay. చూడండి ఇప్పుడు ఈ 2 power 5 తాలూకా ఫ్యాక్టర్స్ ఎవరెవరండి? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5. So what is the power here? 5. So how many divisors less than that? 5. Suppose if I'll give one more question here. Number of factors of, because divisible word is used, so that number of factors of 3 power 7. So here 3 is prime. 7, whatever. 7 or 8 or whatever it is. Suppose if you will take 8 here. Right. So number of factors of 3 power 8. Number of factors of 3 power 8. Write on the comment how many will get number of factors. See here power 5, before that powers 0, 1, 2, 3, 4, 5, so that 5 factors are there. Right. Now come to here number of factors of 3 power 8. Tell me how many number of factors of 3 power 8 is. Okay. First, how many will get write down? Then, what are the factors? We'll list out. Good. See, 8 means here 8 will get. What are the 8? Starts from 3 power 0, 3 power 0, 3 power 1, 3 power 2, 3 power 3, 3 power 4, 3 power 5, 3 power 6, and 3 power 7. 3 power 8, every number divisible by itself, so no need to write. So less than that 3 power 8, number of factors of 3 power 8 which are less than 3 power 8 is 8 factors. These 8 factors. Except these 8, no more factor will exist. Ante kadandi. So ivi kaakunda inkedana factor unda? Does not exist. So దీన్ని సింపుల్ గా మనం ఎలా చేసుకోవాలి? 3 power 8 కాబట్టి less than 3 power 8. So here what we have to observe, the base should be prime number. So ఇప్పుడు ఆన్సర్ చేయండి. Let p be a prime number, n is natural number, p power n divisible by, otherwise number of factors of p power n is what? N. Okay, right. So what is the use of this one, sir? Yes, there is a beautiful use is there. Before going to discuss about that use, let me answer. Let me know the answer. I'll give a point here. For example, from SKL to VSP, there are 3 ways. One is roadway, another one is railway, and the third one is airway. Okay, 3 ways. You can travel from SKL to VSP in 3 ways. Now VSP to Chennai, here it is 4 ways: roadways, railway, airway, waterway. So now answer to my question, in how many ways from SKL to VSP? Chapandi, in how many ways we can travel? In how many ways we can travel here? Respond in that comment section. 7 ways? How it is 7? Do you have any explanation? No. Not like that, not like that. Any more answers? Okay, suppose if you'll choose road, again road, road rail, road air, road water. How many? 4. If you'll go with rail, then in how many ways you can go? See, rail to road, rail to rail, rail to air, rail to water. Again 4 ways. So again air, again 4 ways. Total how many ways? 12 ways. If you'll observe, see, this is 3 ways, this is 4 ways. 3 fours, 12 ways. So this is called fundamental counting principle of multiplication. Fundamental counting principle of multiplication. This is called fundamental counting principle of multiplication. By using this fundamental counting principle of multiplication, okay, fundamental counting principle of multiplication, we have to find a number of factors. What is the concept? Number of factors. So we know prime numbers. So how to use prime numbers? To get number of factors of a number. For example, 72 is a number. 72 is a number. See, number of factors of 72. ఏం చేస్తారండి ఇమీడియట్లీగా ఏం చేస్తారు నెంబర్ ఆఫ్ ఫ్యాక్టర్స్ ఆఫ్ 72 అంటే 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, like you can write. 8 times 9. See, what are the numbers here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total how many? 12 factors are there. Good. What about 2025? How can you do? So if the number is small number, you can split like this. If the number is big, more, then how? Okay, let us see. So, number of factors. Number of factors of a number, given number. This is the concept. Number of factors of a given number. Which example we consider? 72. You know prime factorization. Prime factorize it. So 72, 2, 36, 2, 18s, 2, 9s, 3, 3s. So how we can write 72? How many times 2? 2 power 3 times. How many times 3? 3 power 2 times. Okay. So 72 is equal to 2 power 3 times into 3 power 2 times. Right? Now, see, what are the factors? Because of it is a prime power 3, what are the factors? 2 power 0, 2 power 1, 2 power 2, 2 power 3, total how many? 4. This is in our assumption, this is okay, from SKL to VSP. SKL to VSP. Got it, all of you? Okay. Right. Now, what about this one? 3 power 0, 3 power 1, 3 power 2. Total how many? 3. This is the journey from VSP to CHE, Chennai. Right? So, by fundamental counting principle, four into 3 is equal to 12. So number of factors of 72, how many factors? 12. See, we did here, how many factors? 12. Got it, all of you? That is the use of prime powers. Now see, 2025. Do it, all of you. Try to solve. Try to solve. Try to solve. 2025 number of factors. Okay, so 2025 same prime factorization. Okay, ante change prime factorization. So it is not divisible by 2, it is not divisible by 3, it is divisible by 5, it is divisible by 3, sorry, 3 6 18, 2 2, 3 7s 21, 1 5, 3 5s, again it is divisible by 3 2s, 3 25s, again it is divisible by 3 7s, 3 5s, again it is divisible by 25, it is divisible by 5. So this can be written as 3 power 4 times 5 power 2 times. So number of factors. See, once observe here, if it is 3, this is 4, means 3 plus 1 times. If it is 2, it is 3, 2 plus 1. Okay. So 4 into 3. In the same way, come to here, what is the power here? This is 4, 4 plus 1 times, this is 2, 2 plus 1. So 5 times 3 is equal to 15. So how many factors for 2025? 15 factors are there, right? Okay. Okay. Let K be a number. Let K be a number. Okay. P1, P2, P3 and so on are prime numbers. P1, P2, P3 and so on are prime numbers. Let A1, A2, A3 and so on are natural numbers. Okay, natural numbers. K is equal to P1 power A1 into P2 power A2 into P3 power A3 into and so on. Then number of factors of k is, number of factors of k is. See, by using these two examples, see 4 plus 1, here a1 plus 1 times a2 plus 1 times a3 plus 1 times and so on. This is the number of factors formula. Got it, all of you? అర్థమైందా? సో ఒక ఏదైనా నెంబర్ ఇస్తే how to find number of factors? Simply we can find number of factors. Okay nandi? Suppose we'll do another example. Write down this one. Those who completed will do this question. (1156) 1,444. These two questions have to solve, all of you. 1156, 1,444, number of factors. All of you make it fast and give your answer in that comment section. Okay, prime factoration only. First you have to do prime factoration and then make into prime powers like this. Make into prime powers. Then each power plus 1 multiplied. Each power plus 1 and all the powers consider like that only and consider their product. That is the number of factors of the given number. All of you write down. So దీని మీద మనకి ఇచ్చినటువంటి వర్క్ షీట్ లో క్వశ్చన్స్ ఉన్నాయి, సాల్వ్ చేయండి. So tomorrow also we'll meet again in the same session at 6:30 p.m. tomorrow also. సో ఈ సెషన్లో మనం మెయిన్గా నేర్చుకున్నది ఏంటంటే కాన్సెప్ట్ హౌ టు ఫైండ్ నెంబర్ ఆఫ్ ఫ్యాక్టర్స్. ఒకటి, ఇఫ్ విల్ టేక్ ఎ ప్రైమ్ నెంబర్ p, దెన్ హౌ మెనీ co-primes less than p, how many co-primes which are less than p and co-prime to p. సో ఈ 3 పాయింట్స్ మనం ఈ సెషన్లో నేర్చుకున్నాం. ఓకే, నెక్స్ట్ అప్లికేషన్కి వెళ్దాం. కంప్లీట్ చేయండి. ఫస్ట్ ఆఫ్ ఆల్ మేక్ ఇట్ ఫాస్ట్. మొత్తం స్లైడ్స్ అన్ని కూడా పీడిఎఫ్ చేసి పంపిస్తాను, ఒకసారి గో త్రూ అవ్వండి క్లాస్ అయిన తర్వాత. Right. Only 21. Time? How much time? Okay. Okay, so first one is 1156. Two fives, two sevens, two eights, two twos, two eights, two nines. It is 17. So 2 power 2 times 17 power 2. So number of factors is, see what are number of factors? If you'll observe, so this is 2, this is 2, so 2 plus 1 times 2 plus 1, 3 into 3. which are 9 factors. Okay, right. In the same way, next one also have to do. Right. So now we will see another concept, divisibility rules. Divisibility rules. You know divisibility rules, all of you. Divisibility rules. You know divisibility rules, all of you. So if a number divisible by 2, units place, have to observe units place either 0, 2, 4, 6 or 8. If divisible by 4, divisible by 4, so it is 2 square, 2 square, so that last two places must be 4 multiple. Last two places must be 4 multiple. Suppose 8, this is 2 cube, 2 cube. So last two places, last three places, sorry, last three places must be 8 multiple. Okay, you know 3, sum of digits 3 multiple. Okay, 9, 3 power 2, this is sum of digits 9 multiple. Okay, so based on these 5 rules, remaining also are there. Divisible by 4, divisible by 5, 1 plus 5 are 0. Divisible by 7, there is a beautiful rule is there. Divisible by 9, there is a beautiful rule is there. Divisible by 11. So then suppose 7 to 9 xy is divisible by 4. This is the question. A number of ordered pairs xy. Number of ordered pairs xy. How many values are, how many xy numbers are there? This is a 2-digit number. How many xy numbers are there? This is the question. Right? See clearly what we mentioned here. Last two places must be 4 multiple. Must be 4 multiple. Here what are the last two places? xy. So xy must be 4 multiple. 0, 0, 0, 4, 0, 8, 12, you know 4 table very well, and last one is 96. So total how many? These are the list. How many? How many? How many? This is the first multiple of 4. This is 24th multiple of 4. This is first multiple of 4. This is 24th multiple of 4. So total how many multiples are there here? 1 to 24. And one more multiple is there, that is 0, 0. So total how many possibilities are there? 25. So there are 25 ways or possibilities. Okay, so there are 25 possibilities are there. So in advance, we'll say next application in this only. 182J 2. 724 J 4, 965 J 6. Observe here. And 501 J 8, 123 J 0. Okay. So here, what are the possible values of J? What are the digits J? Once observe here. See, 4 multiples, 12. So J equal to, it may be 1. Again, 22 not divisible by 4. So 3, 5, 7, 9. If 4 will come, what about J? 14 not divisible by 0, 4, 24, 44, 64, 84. Right? Come to here. See, 16, 36, 56, 76, 96. If 8, what about J? Once observe here. 0, 8, 28. So all of you write down this. If one's place is 2, the conclusion is, if one's place is 2, one's place is 2 or 6. If one's place is 2 or 6, possible tens place. What is possible tens place? If one's place is 2 or 6, what are the possible tens place? Possible tens place is either 1, 3, 5, 7, 9. Okay. If one's place is one's place is 4, 8, 0, 4, 8, 0, possible tens place. Questions will come by using these points. Vastayi questions ee points base cheskoni. If one's place is 4 or 8 or 0, possible tens place 0, 2, 4, 6, 8. Okay. So if tens place is 1, 3, 5, 7, 9, then what is one's place? Possible one's place. If tens place is given, for example, observe here, 2, 5, 9, 3, x divisible by 4. Divisible by 4. Greatest possible x is, that is the question, greatest possible x. So divisible by tens place is 3. So if tens place is 3, what are the possible ones place? Tens place is 3, what are the possible ones place? Either 2 or 6. So greatest possible is 6, 2 or 6. In the same way, if tens place is either 0, 2, 4, 6 or 8, what about ones place? Ones place is 0 or 4 or 8. 0 or 4 or 8. Okay. Right. All of you note down these points. Make it fast. Make it fast. Make it fast. ఎప్పుడు స్టార్ట్ అయింది? 10 minutes. Onsi, is there an issue? Okay, so this is the application with divisible by 4, right? Now we'll see with completed. Okay. Write down. No issue. Okay, if you have any network issue, board may be somewhat blurred to you, not for all. Once go through. Once check your network. Anyhow, no need to worry. Already after completion of this class, this video will be available in our channel also. Better subscribe our channel and go through and watch it. Okay, right. Now see, next, divisible by 3 application. Divisible by 3 application. So what type of questions will come by using this divisible by 3? You know, sum of digits. For example, 127J 9Y is divisible by 3. So number of possible ordered pairs J comma Y are is number of possible ordered pairs J comma Y is. That is the question. Yes, you can proceed. Yes, same only. Have to do the sum of digits. 1 plus 2 plus 7 plus J plus 9 plus Y. You know, here it is J and Y are numeric variables. J and Y are variables. The remaining are constants. So 1 plus 3, 1 plus 2, 3 plus 7, 10, 10 plus 9, 19 plus J plus Y. So here you have to observe 19 plus J plus Y is a 3 multiple. Is a 3 multiple which is more than 19. More than 19. Okay. It may be 21, it may be 24, it may be 27, it may be 30, it may be 33, it may be 36, it may be 39, it may be 42. We'll continue like that. Okay, right. See, think logically. Even though if you don't know the topic, you can solve it. Think logically. How, sir? So what is the constant here? 19. Okay. So what must be added to 19? What must be added to 19? What must be added to 19 to get 21? Means you can add 2. You can add 2. What must be added to 19 to get 24? You can add 5. See, what is the difference here? 3. So 5 plus 3, 8. 19 plus 8, 27. Plus 3, 11. 19 plus 11, 30. Plus 3, 14. 19 plus 14, 33. Plus 3, 17. 19 plus 17, 36. Plus 3, 20. And so on. Blah, blah, blah. Okay. See, what is, see here, JY are digits. Here you have to observe JY are digits from where to where? 0 to 9. ఇది గుర్తుపెట్టుకోండి, తర్వాత దీని మీద క్వశ్చన్ అడుగుతాను నేను. JY are digits from 0 to 9. గుర్తుపెట్టుకోండి, క్వశ్చన్ అడుగుతాను తర్వాత. So what is the maximum possible sum of J plus Y from the digits? Maximum possible sum of J plus Y. Maximum possible sum of J plus Y. కరెక్ట్గానే విన్నారు. మ్యాక్సిమం సమ్ ఏమవుతుంది? మ్యాక్సిమం సమ్ you may consider 9 for J as well as 9 for Y. It is 18. More than 18 won't get. ఎవరికైనా వస్తుందా మోర్ దాన్ 18? నో వే. ఎవరైనా ఉంటే చెప్పండి, వండర్ కిడ్స్. ఓకే, రైట్. సో J plus Y maximum sum 18. So from here onwards, no need to take. All right. So you may consider 0 also, because in between them you can consider, see, pairs J, Y, 0, 2, 0 plus 2, 1 plus 1, 2 plus 0. How many pairs? 3. Come to here, 0, 5, okay, 1, 4, 2, 3, 3, 2, 4, 1, 5, 0. How many? 2, 4, 6. This is 3, 6. Come to here, 8, 0, 8, 1, 7, 2, 6, 3, 5, 4, 4, 5, 3, 6, 2, 7, 1, 8, 0. Total how many? 2, 4, 6 plus 3, 9. Okay, right. Now come to here, 11. 0, 11 not possible. Okay, 2, 9, 3, 8, 4, 7, 5, 6, 6, 5, 7, 4, 8, 3, 9, 2. So how many? 2, 4, 6, 8. Okay, good. These are all possible values of JY. And then 14. 14. See, 9, 5. So 5, 9, 6, 8, 7, 7, 8, 6, 9, 5. How many? 5. Sure? Okay. Now 17. 8, 9, 9, 8. Only 2. Okay. So total how many? 3 plus 6, 9, 9 plus 9, 18, 18 plus 8, 26 plus 5, 31 plus 2, 33 pairs for J comma Y. Got it, all of you? It is a beautiful application. It is a beautiful application. In the same way, we can solve one more question. 1, 2, 3, A 5B is divisible by 9. Divisible by 9. You can solve it. Same rule. 1 plus 2 plus 3 plus A plus 5 plus 9. 5 plus B is a 9 multiple. 9 multiple. Right? So 6 plus 5, 11. 11 plus A plus B. After 11, 9 multiple is 18. It may be 27. It may be 36. It may be 45, and so on. So same concept. What must be added to 19 to get 21? Here, what must be added to 11 to get what must be added to 11 to get 18? So 11. So A plus B may be 7. A plus B, here AB are digits from 0 to 9, like JY. Again, 11 plus 16, 27. 11 plus 25. Here onwards not possible, because more than 18 not possible for the 2-digit maximum sum. So that 9, A plus B 7. You can consider same as 0, 7, 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1, 7, 0, 2, 4, 6, 8 possibilities are there. 16. 7, 9, 8, 8, 9, 7. So there are only 3 possibilities. So 8 plus 3, total 11 possibilities for ordered by SAB. Got it, all of you? Now, you have to solve these questions. So divisible by 4, divisible by 8, divisible by 3, divisible by 9. By using these applications, we have to solve more non-routine problems what we posted in our worksheet. Right, sir? Okay. 0, 11, why not possible? This one, See, J you can consider from 0 to 9 only because it is a digit from 0 to 9. Because it is a digit from 0 to 9. That's why more than 9 we cannot consider. More than 9 we cannot consider. That's the issue. Okay. Right. Before going to conclude the session, almost it is 1 hour completed. Because of it is first session, we'll conclude it. So all of you write down. If it is not completed, nothing to worry. I'll post the total notes in our group. Once go through it in our group. See, here we discussed digits from 0 to 9. You know, from your childhood, you're writing numbers using the digits 0 to 9. Why? Writing numbers writing numbers using digits from 0 to 9. Why? It is my question. So tomorrow, before going to start the class, we will discuss about this answer. Okay, all of you get ready with this answer for tomorrow's class. Okay, have a nice day. Thank you. We'll conclude the session tomorrow again at 6:30 p.m. We'll meet. Get soon.